Good morning, software engineers. Happy Thursday. Welcome to the very last day in CSC 370 software engineering. I'm going to ask a favor of you. This is our last day. Please don't start crying. If you start crying, I'll start crying. We'll never get, I almost said it entirely straight. We'll never get through the day. Thank you very much. Come on, you can do it. Our new corporate direction is to monetize virtual reality in multiple simulated worlds called the metaverse. How do we know someone else didn't already do that and we are the simulation? You need to be drug tested immediately. No, I just saw the Matrix. It's okay. We got it? This is the last day you can laugh at these things. You are going to miss them, I know. You're going to wake up December 29th and say, gosh, I wonder what Chuck Norris. A python once bit Chuck Norris. And after 5 days of excruciating pain, the python died. It'd be funnier if like pythons were poisonous, but python's kind of a funny computer. Okay, how about this one? So I went to buy some helps if you could pronounce the words. I went to buy some camouflage shirts today. Yeah, and? Oh, I couldn't find any. Camouflage. I couldn't find. Okay, keep working with me. Oh, hey, speaking of really funny things, we are not having a cumulative final exam. We are having a unit exam. Our exam, I forgot to triple check this, but I'm sure somebody will tell me if I'm wrong. Our final exam period for this class is scheduled for Thursday, a final exam week, 1 to 3 p.m. It's not that long, right? But the exam 3 will be held online at Blackboard. You do not have to come to class. There's no reason to come to class. We'll do nothing beforehand. So you may take it from anywhere you like. The exam will open up approximately 1 p.m. on Thursday, a week from today, and it'll close down, 3:30-ish or so. It is not a 2.5-hour exam, not at all. The exam is, like the other ones, open book and notes, but it is time. So you just choose, you want to start at 1, that's fine. You want to start at 1:30, that's fine. You want to start at 2, that's all fine. Don't start the exam until you're ready to start the exam, and it won't be open before Thursday. Okay, so just like the previous 2, same logistical format. There'll be some true-false questions, about 20 or so, multiple choice, about 7, and then 3 short answer questions. And along with that, there'll be an extra credit question also. Since that we're going to be doing that, why don't we spend much of today reviewing for that exam? If you have questions that I don't cover, be sure to ask. If you want to ask questions now, that's okay too. But we'll go ahead and review. Is that okay? You know who this is? Mr. Bean. You know Mr. Bean. You should look it up. It's big comedy actor in England. So Dr. Manouche knows all about it, but it's pretty funny stuff. So, okay, onward. Whoa, what a surprise. What is software engineering? I'll tell you what, I'm going to ask you a series of questions. Let me answer the first 4 after we pause and you think about it. But then for the next couple groupings, maybe I'll pause a little bit and see if you have any insight to share. Fair enough, so let me model what we're going to do. What is software engineering? Software engineering is the management of the entire software development process. Now, you had to say more than that in exam 1. I will not ask you to go back, but you need to keep that in mind. This class is software engineering. So somehow that word management finds its way into everything that we do as software engineer. Software engineering is the management of the entire software development process. Related question. You think about this for 15 seconds, then I'll tell you the answer. How do we describe software engineering? "15 seconds, it's like an eternity of dead air time." Well, allow me to describe it. I describe software engineering as professional problem solving. That did not shock you, correct? Good. Computer science is problem solving. What's going to separate coding or programming in the small from software engineering, programming in the large? The answer is professionalism. Professionals do things in a different way than non-professionals. And as I mentioned way back when, and also reviewed at the beginning of this unit, don't compare professional and amateur or non-professional, or whatever the opposite of professional is, just on the basis of compensation. Professionals are usually paid, non-professionals maybe not, but that's not the distinguishing characteristic, because we've talked about a number of attributes of professionalism. And in that my list of 10, I didn't see anything there that said salary. Nothing wrong with the salary, but that's not how we describe a professional. All right. So what's software engineering? Management of the entire software development process. How is it described? Professional problem solving. We know some things about professionals. We continue to discuss that in this unit. Thirdly, what's its goal? Why are we doing software engineering? I'll tell you, but please consider it for 15 seconds. Did you consider what the goal of software engineering is? It might help to think back way back when we mentioned some problems with software development. Not explicitly asking that in this unit, but you recall that there were some issues historically and currently with software development, what I usually call the unholy trinity. Software is behind schedule, it's over budget, it's full of bugs. So in a sense, its goal is to somehow deal with those issues. Here's the goal in a nutshell of software engineering. The goal of software engineering is to create an acceptable product. Not done yet. Create an acceptable product following a defined process using professional project management. What's the goal? Create an acceptable product following a defined process using professional project management. So we've seen those issues. Let me come back to the 3 Ps we've talked about a couple times there: product, process, and project. We'll do it right now. So what's software engineering? How's it defined? What's its goal? How is software engineering carried out? How do you do it? Do software engineering. Okay, take 15 seconds. How do you do it? Here's the concise answer. Very concise answer is the software development lifecycle, the SDLC. How do we do software engineering? The SDLC is a process. It's the process we follow. But we've already talked about management, and that's the project. And then we've talked about also an acceptable product. All those things are related. Product, process, project. How's it carried out? The software development lifecycle. And for most folks, there's a philosophy that we wrap around these phases. The one that we've done most, or at least pretended to do, is Scrum. What's Scrum? Scrum, strictly speaking, is not a software development lifecycle. It is a way of thinking about the software development lifecycle, saying, okay, do it in tiny sprints. Requirements, specs, design, deploy. I'm sorry, better instantiate before we deploy. Recs, specs, design, instantiate, iterate, iterate. So it's one of the many agile methods. It's not the only one. One other one we talked about two other ones. So Scrum is the one we've done the most. So you probably should remember some things about Scrum. Another one we've talked about is DevOps. DevOps, again, is not a software development lifecycle, but it's a philosophy, it's a mindset. It is, hey, take these two groups of people that classically are separate, the development engineers, us, and the operators, clients and users, put them together so they can talk about it. A third philosophy that we sort of saw a tiny bit, Kanban, comes from the Japanese word for Post-it notes. No, it comes from billboard or something like that. And the idea of Kanban was to not only be sure that you can see everything, but your doing list is really short. You don't multitask. You focus on one or a very small number of things. All right, how's it carried out? Software development lifecycle and some philosophy that we wrap around that. We might call it Scrum or similar. Good. Let's review those phases then for just a moment in the software development lifecycle, and let me connect it to its bigger container. So the first two phases, which was Unit 1 of CSC 370, requirements and specifications. I will not be asking specific questions about this. I would hope that you wouldn't forget, but we're focusing on the last two. Requirements, all about the why. Why is there a problem? Why do you need a computerized solution? Specifications, all about the what. What are the features and functions? What does a good solution look like? At the highest level of abstraction, I think of this as the idea. The idea of the solution comes from the idea of the problem. And we get both of those in focus by doing requirements and specifications. Here's my mental model of what's happening. The next two phases, the middle unit of CSC 370, were design and instantiation. Keyword associated with both of those phases is how. How will the product actually solve the problem? First of all, in design, and secondly, in code. We're moving from the conceptual idea into the concrete implementation. I got this great idea, do it. Let's see something out of that. That's the implementation. In most coding classes that you've had, the actual focus is on the instantiation. I mean, somebody's already kind of giving you the design. Some of that work is yours too. But you can always pick that up in the context of whatever Dr. Lipman's talking about at the moment. So much of our focus has been on instantiation. And you notice, as I said way back when, in this class, that's the least thing I'm going to focus on. I try not to show you any code. I try to be intentionally vague if you ask me those questions. You're going to learn it by figuring it out. What we want to do in this class is put the bigger wrapper around this interesting but small part of software development instantiation. Now, so the last third, the focus of this last unit, the last two phases are deployment and maintenance. Deployment and maintenance. What are some interesting things we've said there? We'll go in a little more depth in just a moment on each of these. But some interesting things we talked about during deployment was the whole concept of interaction. What good is a product if the user doesn't employ it to solve a problem? If users don't interact with your product, what good is it? That's rhetorical. The answer is it's not good at all. There's some other kinds of interaction. Another kind of interaction is developer interaction. What about from one developer to another, working as part of a team? How might you divide up responsibilities? Well, I think you've done that in practice. Interaction is how the user knows that you solved the problem. This is another aspect that you don't really experience a lot in the other coding classes. Once you can get that stinking thing to compile and run, then you throw it over the wall to Dr. Lipman, and you don't want to have to think about it again. But that's not how software engineers do it. We, first of all, interact with it and make sure it really works before we throw it over the wall to our user. And even then, we're not done, because then comes the final phase, and that's maintenance. We'll define it in just a bit. But an interesting thing we said about maintenance is how much time and effort this takes. Maintenance is the biggest factor, both time and cost, in software engineering. Most studies indicate 2/3 of the cost of any product is wrapped up in maintenance. We mentioned a couple different kinds of maintenance, like the corrective maintenance. That seems obvious. Oh, there's a bug. We got to fix it. And it's not that simple, because you need to fix the error without introducing new errors. So we are very much interacting with our own code, which means that I sure hope I created using professional source code practice so I can read it and understand it. All right. So what is the deployment phase? If you're wondering why I'm asking, if you think back to the previous two exams, remember each unit exam focused on 2 phases software development lifecycle. And you might recall that there was a short answer question about each of the phases. So it's entirely possible I might ask you a question along the lines of, what is the deployment phase? And what does interaction got to do with it? I'll probably phrase it as, tell me some aspect of user interaction. User interaction was our discussion on UX, user experience. What makes a good user experience? Oh, well, how about an app that isn't buggy? Maybe a good user experience. How about an app that is robust? It's not fragile and doesn't break if I, as a user, do something, I won't say stupid. I do something that was unexpected. During deployment, what about developer interaction, one to the other? So how would you define, what does deployment mean? Anybody want to answer? The answer is no. You want to impress me? Point. You want to impress me? Darn. We defined it something like deployment, software deployment. Software goes without saying, right? I mean, why do I always throw software? Includes all activities ensuring a software product is available for use. Software deployment includes all activities ensuring a software product is available for use. Yes, when it's deployed, it goes somewhere. Where does it go? It goes from us, developer, to the user, so the user can employ it to solve a problem. What are some issues? We talked about a lot of things there. We talked about, the importance of everything from physically distributing it to marketing. And during both deployment and maintenance, we mentioned a couple very specific things like that big O notation for the analysis of algorithms. The user says, okay, this solves the problem, but it's not as fast and peppy as I hoped. So then we say, oh, well, the algorithm that we deployed was of the order whatever. Can I get something faster and more efficient? Can I change it to a different order? Sure. We talked about a lot of things in the deployment phase. I guess one other thing I'll mention is the EULA, EULA, the End User License Agreement. You recall that software is not sold. You don't own it. It's licensed for use. The license governs aspects of copying and distribution. Although we talked about this during instantiation, we also talked about it during deployment. Software engineers, we create professional source code. Many people can throw out C# statements at a problem. Professional source code is a little different. It has some characteristics or attributes. We discussed things like meaningful variable name and white space and indentation, all those things to give us some insight into what's happening here. Why? Not only is it more effective when you're instantiating it as part of a team, because then both people on the team can recognize what the other person did, but it's going to be important later in maintenance. Professional code is readable. It's when John Scully say, it's just like a work of literature. It's beautiful. It's readable. So human beings can understand it. Yeah, very good. We talked about ethics a couple times in this unit, both in the context of deployment, context of maintenance, maybe even out of those when we talked about the philosophy of software engineering. How does ethics relate? Ethics, the word that I use here is ought. How we ought to develop software. How should we do that? Well, how ought we to deploy things? That is applicable here also. Ethics is the should, the ought, and we'll see in a little bit, there are some guidelines involved also. But you think about that. What about testing? Let's review some general things about testing. Testing should be done throughout the software development lifecycle. Testing is not just for the end of instantiation. Testing is something that's done throughout the software development lifecycle. Would we test in deployment? Yeah. But when we talked about testing how we deploy. And the other thing is figuring out how to do regression testing. I tested once in instantiation before I deliver, but I know I'm going to have to retest. So can I automate the testing process? The regression testing idea is something else to think about. Okay. Deployment phase, so review what it is, how it's carried out. Context of interaction. Think about an aspect of developer interaction, what that might mean during deployment. And you think about an aspect of user interaction. Easier to think about, that's the user experience. Maintenance. So the last major phase is maintenance. Will there be a question on the exam about maintenance, like what is the purpose of the maintenance phase and how is it carried out? Oh yeah, very likely. Yes, absolutely. There will be. There's lots of questions on deployment, lots on maintenance, but a short answer question on deployment and a short answer question on maintenance. What is it and how is it carried out? Our concise, succinct, but probably too short definition of maintenance is any change to the product after deployment. Any change to the product after deployment. And remember, product for us, software engineers, is code plus documentation. Any change to the product, code plus documentation after it has been deployed. Let's see, I already mentioned this is the biggest thing, right? One of the horrible things that happens logistically, poor people management, is oftentimes junior software engineers, brand new software engineers. They join the company, we're all smiling, ready to go. What do they give you? Hey, go maintain this code. Well, it's true. Very few people want to do maintenance. It's extremely important, and most people end up doing it. But maintenance is hard. It's difficult. Surveys show time and again, it's easier to create a new product than to maintain an existing product. Even if we put the constraint on creating the product well in a professional way. Easier to create something new without the constraints of the existing framework than it is to modify something that already exists. Did we mention the 4 types of maintenance? I only talked about corrective. Then there's also perfective maintenance. If we're doing perfective maintenance, it's not a problem with the original product per se. It's more like an enhancement. The user says, oh, this is really cool. Hey, could it do this? And the answer is, yes, of course it can do that. That wasn't part of the original spec, so we didn't do that. So, well, can we add this? Yeah, that's possible. Or maybe it's, when I never thought about how long this is taking, and it does solve the problem, but gosh, to take 20 seconds, can it be faster? Maybe. Those are examples of perfective maintenance. A third type is adaptive maintenance. Adaptive maintenance is a change to the product due to a change in its environment. Maybe the hardware changed. Maybe it's a new feature of the operating system. So now I have to adapt the product to the new hardware or the new operating system. The fourth one, we didn't go into depth, but boy, this is hard. The fourth one is the preventative maintenance. I give you a good example with cars. Change the oil in your crankcase because it helps prevent problems. Don't wait until it turns into sludge. How does that apply to software? It does, but it's something way up there. So let's just say, yeah, it's another type. It's possible. The other ones we'll focus on here. Part of maintenance is an activity called configuration. Sorry, I had to abbreviate it or go to a really tiny font. Management, MGMT. Why configuration management? You can answer that question if you know what configuration management is. A configuration is a current state of the product. A configuration is a current state of the product. Configuration management, oh, notice the word management. Hey, sounds like software engineering. It's this aspect of, especially when you're doing maintenance, to say, okay, well, here's the original, and here was corrective update 0.1, and here's adaptive update 0.05. How do they all relate to each other? Somebody needs to keep track of it. You need to know this is what we're working on, not this. And then when you release something, you need to make sure you can identify that versus the previous version. Some people will refer to configuration management as version control. All righty. How does Scrum relate to all this, but especially to maintenance? Well, as it turns out, I mentioned that many people don't believe that Scrum is a good philosophy to put around the maintenance phase. Seems to work pretty well with the first 4 phases, but when it comes to maintenance, Scrum is not the best possible approach. When we said that, that might have concerned you because you said, well, isn't Scrum? No, Scrum is just a philosophy. The framework we're using is the software development lifecycle. Requirements, specifications, design, instantiation, deployment, maintenance. Scrum is a way to look at that. And we saw a couple times ago that Scrum, because maintenance requests can arrive at any time, and because they're usually time sensitive, some people don't think Scrum's a great way. I think at that time when I mentioned that, we saw the little video on Kanban as maybe a better philosophical approach. But everything we've talked about applies. I mean, we're still managing things, we're still following a process. It's just the philosophy behind it. Scrum was overarchingly is defined as a framework for developing and sustaining complex products or projects? Let's say products. Scrum is a framework for developing and sustaining complex product. It was designed to originally deal with complexity. And that's what we have to do, software engineers. We deal with complexity, abstracting things, taking a look at how do I break down architectural design, etc. Good. What about testing? Must have got ahead of myself because we already mentioned testing during deployment, but we could talk about it in maintenance. It's apropos here. The concept of regression testing. Regression testing is retesting. Why should I test again? Because you've made change. You don't believe that your changes were perfect, do you? Your original code was not perfect. You had to maintain it. Why would you believe your changes were perfect? You must still believe in Santa Claus. Testing, and here we also talked about the concept of automating tests. Since we're going to have to test and then retest and then retest, it would make a lot of sense if we automated the testing process. Very good. This is the last time we can develop in body. Would you like to stand up? You would. Good. Okay. And I need to come up with another list of all the benefits of standing. Please try to take notes while you're standing. You're looking for something to do, so we've got to look up what's that video called? I can't show it in this class. When Hitler discovers that Chuck Norris is coming. Anybody see that? Yeah, there's a lot of great Chuck Norris lines in there. Okay. Speaking of Santa Claus, Hitler's the worst day of his life is not when he discovered that Santa Claus wasn't real. It's when he discovered that Chuck Norris was. I'm going to keep going. Give you something to think about. Did I have the date right? Okay. 9 + 7, that's 16. Seems really late, right? Finals week is really late this year. Oh. Good. If you have a question before the exam happens, be sure and come find me. Send me a message, do whatever it takes. Okay. And if you'd like to take the exam standing up, you may do so. I'd say you could come in this room and do it, but I don't think, are any of these plugged in? You'd have to bring your own extension cord, plug in, and then the desk will. How long has the desk that was here been gone? Like 3 months? Used to be a desk right here. Has there been a desk right here at all this semester? Well, there was. Where'd it go? I was going to demonstrate how it goes up and down. You had enough? Good. Would you like to sit down? Sure. Go right ahead. The other thing I'll ask you to review and think about was the article that we read in this unit, and that's Fred Brooks, the computer scientist as toolsmith. Just think in general what he's saying, and I'll review the idea of a toolsmith again with you near the end, but really Fred Brooks is saying a lot of things that initially could shock us. First of all, computer science is not a science. It's an engineering discipline. Now, I happen to disagree with that, but they didn't name the computer science building after me, so we won't get into it in this class. But computer science is a constructive, creative engineering process, not a scientific discipline. And then you notice how much in this article Brooks talks about collaboration. Not only working with other computer folk, but working with users. Software development, according to Brooks, is a collaborative endeavor. developers working with clients and users in a professional way. So just take a look at that. That might find its way on the exam also. Good. Hey, would you like to introduce yourself? Last time you can do this. I'm looking back, my fault. My goal was to do this at least once a week, and I didn't quite get there. But here it is. So, are you looking forward to something during break? Are you looking forward to anything? Are you looking forward to going somewhere? Are you looking forward to seeing somebody? Are you looking forward to doing something? We do have a break, right? Yeah. So during the break, which for you cannot begin before Thursday because you got to do that on Thursday. Oh, but I guess we got to talk about the project, not the project, but the final sprint of the team development project. But after all that, are you looking forward to something? Sure you are. Okay. Who'd like to start? Well, people out in Zoom. Okay, we're going to start out in Zoom land. Are you okay with that? Sure. Okay. Now the order that I see is different than the order that you see. So you're going to be surprised. Songwon, would you mind unmuting and tell me, are you looking forward to doing anything over the break?
Yes, I'm looking for to learn skateboarding.
Oh, really? Where are you
Yeah.
going to do, where are you going to go to do that?
Here.
Here?
Yeah.
Are you
From
going to,
YouTube.
you're going to clear the snow out of the way to do that?
I mean not snowboard, like actual skateboarding.
Right. I know, but I mean, there's going to be snow on the ground.
Yeah. But I can try.
Okay. Sorry, I was just curious. I was just wondering. Good. Okay, skateboarding. Got it. Thank you. Good. Chloe, I see you next. Would you mind unmuting and telling us if you're looking forward to anything?
I'm looking forward to seeing my sister and my cats.
Ah, good. So is that home someplace?
Yeah, my home's a couple hours north where my
Okay.
cats live, but my sister lives in Oregon and I don't get to see her too much, but she'll be home for Christmas.
Oh, nice. Okay, good. Thank you. Thank you. Adir, I see you next.
I'm excited to go back home. I'm going to visit my family back home. So
Okay, good. And where is home?
Israel.
Oh, wow. Okay.
Yeah.
Good. Okay, thank you. Thank you. Calvin, I see you next.
I am excited to go back to work.
Where do you work?
I work at Thrift Books. It's a used book company and I work in the warehouse.
Oh, okay. All right, good. Thank you. Reese, I see you next. You'll need to
I'm
unmute.
looking forward to fixing my PC.
Okay, good. Thank you. Is that everybody at a distance? Okay, so folks, okay. So folks here, we're going to end with Elaine because I'm always looking at her first. So Linus.
Looking forward to seeing my family.
Okay, seeing your family here, or you have to go somewhere?
Yeah.
Ohio. Okay, good. Thank you. Kevin.
Yes, I go back to work and see my
Okay, good. And where's work?
It's called Round Lake. It's my
Oh, okay. All right, cool. Very nice. Good. Justin. Christmas. Okay, good. Thank you. Jordan,
I'm excited to go back home,
just to go back home. And where's home?
Arizona.
Oh, wow. Yeah, that would be nice. Trevor?
So can I count snakes?
Oh, wow, yes. Today, happy birthday.
I'm excited to sleep, dominoes, and play against them.
Okay, all right, nice. Thank you. Ross, there's no, Ross?
I'm looking forward to celebrating Christmas.
Okay, Christmas, good. On?
Looking forward to close past my
Okay, good. Sean?
looking forward to not thinking about fun.
Okay, we won't make you think about it. Good. Adam?
Looking forward to seeing my parents' new house,
Oh, okay, and where's that at?
Minnesota.
Minnesota, okay, good. And Elaine? Okay, good, and where's family at? Missouri, okay, nice, good. Thank you all very much, I appreciate that. Those are all great things. I'm glad you have something to look forward to. Just wait a week, except for Trevor, he can celebrate his birthday today. Nice. All right, I'm going to ask a favor of you. In your spam box, you'll find an email message that asks you to do the course evaluation. You have the opportunity as a student to evaluate all the courses that you have each semester, including this semester. And I'm going to encourage you to do this. And in addition to that, I can usually get about, if they don't say anything, usually about 60% of the folks do it. If I say, please do it, then sometimes about 70% of the folks do it. Well, I'll tell you what, if I can get, there are 19 people in this class, one person has already done it. Good for you. I don't know. If I can get 85% of the people to do this, I will give you extra credit. You can get 10 points of extra credit for doing this. But you're going to have to do it before next Thursday. So sometime between now and next Thursday, if you find the time to do the course evaluation, if you haven't done these before, standard stuff, fill in the box from 1 to 5 or whatever they are. But I'll also ask you to do something specific for me. There are 2 questions that are kind of free form, just type in whatever you want. One of them, question 20, I don't know what the S is in it, but what did the instructor do well to help you learn this course? You can answer that, but what I'd like to also know is, what interesting thing did you learn in this class? You don't have to write what you think I'm expecting. Oh, I thought the SDLC was the most interesting thing in my, no. What interesting thing or things did you learn in this class? That would be very helpful to me just to get a sense for those kinds of things. Remember the course evaluations, these are anonymous. I do not see either who does them or what exactly they say. What I do see is this aggregate like you see right here. This morning I looked and it said, one of the 19 of us have actually done it. This report, I don't even get to see the report at all until after I need to submit grades in the class. And all I see is an aggregate. This is what 19 people said or whatever it might be. So if I can get, 85%, that's like 16. We get 16 out of 19, then you'll help yourself, you'll help everybody else. We'll do 10 points of extra credit. But you need to do it, I'll say before next Thursday. I want to get that plugged in such that once the exam is done, then we all know and we're out of here. Fair? Thank you. Let me review something. I know I talked about once, and it was on the video from last time, but I know that was it. I appreciate you allowing me to do that. I was attending a family funeral in Nexa, Missouri, that's south of Springfield. I just needed to be there. So I was gone all weekend and then through Tuesday. So thank you for allowing me to show that video from last time. Let me review this idea with you, the concept of work. Work, it's going to be hard for me to convince you of this. Work is a good thing. Human beings were originally created to do work. Read all about it in Genesis 2. Now, the problem with work today is something we call sin, and the fact that we have to deal with ourselves and other people and things like that. But work is actually a good thing. So for those of you that said, I'm looking forward to going back to work, good for you. But you were saying just because you weren't in school, but I understand that. I divide the world of work into 3 types. The first type is what I call a job. A job, the primary purpose of a job is to earn money. That's a good thing. When I was an undergraduate student, I worked as a mechanic in a Ford Motor Company garage. That was a job. I didn't plan on doing it my whole life. I did it so I could earn money to pay for college. Many of you have jobs right now. Purpose of a job is to earn money. Nothing wrong with that, it's good. There's another type of work. And the second type of work is what I call a career. The purpose of a career is to earn money, just like a job, and be fulfilled. So with a career, you can not only earn money, but you can be fulfilled or satisfied. In other words, you like what you're doing. Not everything. Gosh, I mean, there's some things about being a college professor I don't enjoy at all. But for the most part, yeah, really good. When I graduated from college, I went to work for Hewlett Packard Company. I earned money, pretty good money, and I really enjoyed what I was doing. It was a career. There's a third type of work, and that's the concept of vocation. It's very much a Christian-oriented term. So what's the purpose of vocation of work? Well, believe it or not, in a vocation, you can earn money. That's good. You can be self-fulfilled. And the most important part of vocation is you are loving and serving other people. Primary purpose of vocation is to love and serve your neighbor. Being a computer scientist, we can do that. We can create good tools that other people can use to solve problems well. That's a way to love and serve our neighbor. So no matter where you currently or in the future fall in the spectrum, I would encourage you to think about vocation. Now, some vocations, some things that we do to love and serve other people don't pay as well as some other jobs or careers do. I mean, you might find this surprising, but when I left industry, they didn't pay me as much to teach as they paid me in industry. And as a matter of fact, I have students leaving here that are earning more than I'm earning, but that's okay because there's something else involved here also. Job, career, vocation. I would hope that you would think about computer science as a vocation. Yes, it's a way to earn money, and yes, it's a great way to be self-fulfilled, but primarily it's a way to help other people, love and serve your neighbor. We've talked a lot, or I've talked a lot about professionals. What separates a professional from others? We did this little thing way back when at the beginning, and I've shared some things along the way. But one of the key distinguishing factors between a professional and a non-professional is professionals demonstrate a passion for their vocation or job or career. Paul writes in Colossians 3, whatever you do, work heartily. That's a funny word. Work heartily as for the Lord and not for human beings. In other words, be passionate about what you are doing. Yeah, we could say professionals are paid more and professionals know more, but a better distinguishing characteristic is a passion for what you do. Much of software engineering, I've revolved around this concept of creativity. Software engineering is a creative endeavor. Creativity, I believe, has three aspects. Any creative process, whether you are doing a musical composition or a sculpture or an app, idea, maybe you remember this, implementation, and interaction. There are three aspects to the creative process. Sometimes people say, well, just, come in with that idea. That's the creative part. No. It's all these things. And although I've listed them in this order, idea, implementation, interaction, the creative process isn't linear. It's like the software development lifecycle. Sometimes the best ideas come when people are interacting with the current thing and saying, why can't we do this thing better? I've shared this with you, but I just want to make sure you know, software engineering is really a logical extension of human creativity. And that human creativity really comes from God. If you've read, I try to give homage to Dorothy Sayers in her work because she was the person that I first finally figured this out from in her book, The Mind of the Maker. The primary purpose of her book was try to explain the Trinity. Well, good luck with that. But she did it by talking about the three aspects of creativity. And I stole that idea from her. And I'm in good company because Fred Brooks stole that idea from her also. Trinitarian, yes, God is triune. And people create in that way because we were made in God's image. But don't write that down. I've said that 3 times. But if you think about it, we mirror God's creative activity. Think about the triune God and how God created. Now, God is 3 persons in one, so it's doing a little disservice to just say that the idea of creation only is God the Father. God had the idea of creation. But certainly God the Father had an idea of creation. If you read the biblical text carefully, you will see that the Bible says God created everything. But then it identifies Jesus, the second person of the Trinity, the Son, specifically as having what I'll say the energy to create the universe. Read about it in John 1 or Colossians or Romans. Whoa. Keep going. There we go. And then the third person of the Trinity, now again, God does the interaction. But the biblical text does point out that it's the Holy Spirit that has the power to inform us of the meaning of creation. Read about it in Hebrews. We wouldn't know about creation. We wouldn't know about origin unless the Spirit had interacted with us through God's word, gave us that understanding. So our creative activities in software engineering, in a very small way, mirror God's creative acts at the beginning. We ended up talking about the philosophy of software engineering. So that was pretty recent in our minds. Just look at those last couple of days to see some things there. But I did ask you to think about this. In the world of software engineering, Which do you think is more beneficial? Which would allow us to create better products? Focusing on and having a very good process, or focusing on and having very good people? It's a false, it's not an either or, it's a false dichotomy. It's not like I only get either good people or a good process. Of course, it's entirely possible to have both, and it's entirely possible to have neither one. But which one is more beneficial for software engineering? Having a very good process in place, or having very good people employed? I'd like you to think about it. Why is he saying that? Probably because he's going to ask you that question. But when you answer that question, I want you to think about it in terms of software engineering. If you just say, well, I feel that, okay, that's good. I'm glad you feel that way. Give me some heft, support it somehow. If you think good process is more important, support that using software engineering. If you think good people are more important, support that using software engineering. Makes no difference to me which you say. I'm just looking at how you're thinking about that issue. Good people, good process. I suppose you can look at it this way. You had your choice of two companies and you know them very well. One company has a really good process, but the people there are fine. You know, there's no superstars there. The other company, there's no process in place, or if there is, nobody follows it, but it's full of superstars. Which one are you going to pick? I have identified the software development lifecycle as a framework. Software engineering, how do you do it? The answer is the software development lifecycle, and then some philosophy over that, whether that's Scrum or the thing you can't read that just says Agile. So what's the framework for software engineering? How's it done? Software development lifecycle, Scrum, you bet. Then every week, I've tried to mention there's some good guidelines for life too. And those are found in the 10 Commandments and the biblical text. So I've related an aspect of professionalism to one of the commandments about each week. Not quite, but there you go. But I don't want to leave you uninformed. The purpose of the Bible is not just to provide us with laws. Oh yeah, there's 10 Commandments there. There's the moral law. The Old Testament has ceremonial laws and other things too. Don't apply to us today. But the moral law, yeah. It's not just to provide us with laws. The purpose of the biblical text is to show us the means of salvation. Human beings, we blew it. There is a way out of it. And that's what the biblical text shows us. So I've been focusing on the 10 Commandments, but I've also been trying to focus on the positive aspects of them. It's not just law, it's also gospel. The problem is law only works externally. You know, you can say, hey, do this, do the requirements first. I don't want to do the requirements. That just works externally. It's just like speed limits. The gospel, the more important message of the biblical text, works to change the inside. And once your inside is changed internally, then the external works also. So law and gospel, as you've discovered in Religion 110, the two major themes of the biblical text. I didn't want to leave this as only law guidelines. They're good guidelines, but ultimately they're not nearly as important as gospel. Darn, will this be the last one? Chuck Norris has only failed at one thing: losing. The stork delivers babies under 7 pounds. Oh, yeah. What about the heavier ones? Oh, for those, you need a crane. Oh, speaking of babies, since Christmas is coming up, I do want you to have a Merry Christmas. At the same time, I would like you to think about the person of Christ. If you don't know anything about Christ or Christianity, I would encourage you to investigate it. I think it's time well spent. If you don't know anything about the person of Christ, would you spend a little bit of time investigating? You don't have to do it on your own. There's lots of people you can ask. Boy, Concordia has some great folks. We have 2 outstanding campus pastors, and Steve Smith and Doug Bender, and a whole philosophy and theology department full of folk. You can even ask somebody in computer science. This is a little more important. Can I say it? Knowing the person of Christ is more important than software engineering. Yeah, there I said it. Concordia University, Wisconsin is a Lutheran higher education community committed to helping students develop in mind, body, and spirit for service to Christ and the church and the world. That's our mission. And I hope that I've helped to do that, to connect Christian worldview and software engineering. That's been my goal. You can share that with me in the evaluation. I've been attempting to connect these 2 things in a meaningful way. I was always angry, and I had a huge hole in my heart. Nothing made me happy. Then I got married to a God-fearing woman, and at home she would read the Bible every morning. After a while, she said, "Do you want me to read aloud to you?" So I sat down. She started reading the Bible aloud to me every morning. Eventually, I said, "Well, let me read it." And so I started to read it aloud to her. And then it was like the Lord said to me, "Chuck, it's time to come home. It's been long enough." And now my heart is filled up again. So that's not a alleged fact. I mean, that's really Chuck Norris. And I hope I look that good when I'm 80. That's not going to happen because I don't look that good and I'm 60. So I don't look that good at all. Chuck thanks you for being here. He does. He knows that I integrate him in my class. You can come read my poster in my office. And he thanks you for being here also. The Lord spoke to Moses saying, "The Lord bless you and keep you. The Lord make his face to shine upon you and be gracious to you. The Lord lift up his countenance upon you and give you peace." This week, next week, not a lot of peace. But worldly stuff, probably won't find it there. Heavenly spiritual stuff, you absolutely will. This is the coolest. Chad Bird, nobody's free to know him, a theologian down the road at Wisconsin Lutheran College. In the face of Jesus, we see the Father's smile of grace and favor, for in him we are blessed by the Spirit. So hopefully this is Christmas for you too. You could be out of here and you could think about something different and even something more meaningful. Before I see if you have questions, let me just say thank you. Thank you for being part of this class. I enjoy software engineering almost as much as I enjoy the theory of computer science. For those of you unlucky enough to think about theory, that'll be me also. But I was privileged to be a software engineer at Hewlett Packard for 10 years, a long time ago. And then I get to teach about it and actually do some things on the side. So I've appreciated you being here, first of all, because if the truth were known, it's your tuition that pays my salary. So thank you very much. Do you have any questions or comments or concerns here at the end? What if I failed to address? Yes, the final sprint. When you look online at Blackboard, you see there's a couple things, at least one assignment I want you to do, the team assessment. There were a couple extra credit ones, beyond the one that I just mentioned about getting 16 people at least to do the evaluation. But then there's the final sprint. So the final sprint, as the previous one, so you didn't have to upload sprint 3. Upload your full and complete Visual Studio solution. Upload that. You could zip it up and upload the whole thing. And be sure there's some documentation. Be sure the user, me, knows what to do with it. And of course, if you got questions, feel free to ask. Questions, comments, concerns? We're done. Have a nice day. Have a happy weekend. Don't forget to take the exam next Thursday. I'll be seeing you around.